Hello. In this video, we're going to be introducing GitHub Actions Importer and how you can use the product to migrate your workflows to GitHub Actions. Before we talk about what GitHub Actions Importer is as a product, it's helpful to outline the various phases that come with a migration to GitHub Actions. The first phase of any migration is planning. Some activities in this phase involve looking at your current CI/CD footprint to understand how many pipelines you have defined, any complexities that you should be aware of upfront, for example, if you have customizations built on top of a CI/CD provider, and trying to build a timeline of what pipelines are ready to migrate immediately, what pipelines need a little bit of work prior to being migrated, or what pipelines should not be migrated at all. For example, if you have a legacy or a defunct pipeline. The next phase of a migration is forecasting. This activity involves looking at your previous usage of your CI/CD systems and forecasting the amount of usage you'd have in GitHub Actions. This is incredibly helpful to understand the number of runners that you're consuming and the types of runners you're consuming so that when you migrate to GitHub Actions, you have the number and type of runners available in order to meet your demands. And the final phase here of automation is more traditionally what you'd think of when you migrate to GitHub Actions, where you are converting a single pipeline to its equivalent workflow and validating that the behavior and functionality is the same. Once you've validated this behavior, this new workflow can be added to a GitHub repository, and the migration is complete. Doing all three phases manually is not only very tedious, but it is incredibly error-prone. That is why GitHub Actions Importer was created. GitHub Actions Importer is a tool to both plan and automate your migration to GitHub Actions. There are 5 CI/CD systems supported by the product. And the goal of any migration, any converted workflow, has a goal of converting at least 80% of any given workflow. The remaining percent must be converted manually, and as such, any output of the product should be reviewed with human eyes prior to taking it as your production workload. So let's see it in action. In this demo, I'm going to be showing how GitHub Actions Importer can be used to help migrate your Azure DevOps pipelines to GitHub Actions. Actions Importer is distributed as a Docker image and an extension to the GitHub CLI to interact with that Docker image. The first CLI command that you should run when you are setting up your environment to perform these migrations is the configure command. This will start an interactive command prompt to store all of the credentials needed in order to authenticate with your Azure DevOps organization and the desired GitHub repository you're migrating to. These credentials are persisted into a .env file, so this configure command can be run once and have it persist across all of your migration events. The next CLI command you should be running often is the update command. What this will do is fetch the latest version of the Actions Importer Docker image so that you are on the latest and greatest version of the product. Now, the next CLI command we will be looking at is the audit command. What an audit will do is fetch all the pipelines defined in your Azure DevOps organization, convert each of those pipelines to their equivalent GitHub Actions workflow, and then write a report that summarizes how complete of a migration you're looking at today. In this example, I'm going to be running and including only the pipelines that are defined in the integration test folder of my Azure DevOps organization. When this command completes, you will see a list of files written to disk, and the last of those files is the audit summary file. So let's take a look at what these file contents are. The audit summary is a pretty simple markdown file. However, the data contained within it is incredibly powerful to help you plan your migration to GitHub Actions. So here we can see in this Azure DevOps organization, there are 122 pipelines defined. 112 of them are considered successful, meaning all of the constructs of the pipeline, the build steps, the stages, the jobs, were converted to their equivalent construct in GitHub Actions, and all of the individual items, the individual build steps, the individual build triggers, were converted to their equivalent action. 3 were considered partially successful, meaning the main constructs of the pipeline were converted. However, there may be a build step or an individual build trigger that was not automatically converted. 0 are using an unsupported pipeline type, and there were some failures here. Now we see a breakdown of all the job types used across these 122 pipelines. We can see there were designer jobs, your standard classic build pipeline, YAML-based pipelines, and release pipelines. So GitHub Actions Importer supports converting all 3 of these job types. So any job type you can configure, any pipeline type you can configure in Azure DevOps is supported by GitHub Actions Importer. Next, we see a list of the build steps that were referenced across these 122 pipelines. 408 of them are considered known to GitHub Actions Importer, meaning when this build task was referenced in a pipeline that was being converted, Actions Importer knew exactly how to convert it to its equivalent in GitHub Actions. Similarly, there's a breakdown of the unknown build steps, meaning steps that were not able to be converted automatically, and a list of unsupported build steps, meaning fundamentally the behavior that they exhibit in Azure DevOps is not compatible with GitHub Actions. You will notice that there are a handful of GUID-based task identifiers here. This is typically what happens when you have a build task that is either auto-injected by policy or a build task that is configured solely in the classic designer pipeline. Finally, here we see a list of all of the actions that were used in order to convert these 122 pipelines. This list of actions is a fantastic resource to start planning any compliance reviews or security reviews so that you, the person performing the migration, know exactly which first and third-party dependencies you will be taking once you migrate to GitHub Actions. There's a similar breakdown here for build triggers, environment variables, and a catch-all other category. Finally, here we see a list of manual tasks. Now, what a manual task is something that was not able to be migrated automatically by Actions Importer. So in this case, an encrypted secret. So these pipelines that reference these secrets will need this value populated in GitHub in order for them to be completely valid. Same concept applies for self-hosted runners, where pipelines may reference a self-hosted runner in Azure DevOps. However, it is up to you, the person performing the migration, to validate that these self-hosted runners exist for the repository or organization that you're migrating to. And then finally, here we have a manifest of all the files that are written to disk during this audit. Generally, there'll be 2, 3, or 4 files written to disk for each pipeline. One for the original pipeline definition in Azure DevOps, one for the network responses from Azure DevOps that were used in order to assist in converting that pipeline, and one or many for the converted workflow or reusable workflows in GitHub Actions. The next CLI command that we will look at is the forecast command. What a forecast command will do is fetch all of the jobs that were completed after a specified start date. So in this case, all of the jobs that were completed after October 1st, 2022. Then the forecast command will use that data to calculate metrics that show what your total consumption was of your build infrastructure in Azure DevOps. As before, there is a list of output files that are written to disk during this forecast command. And let's take a look at this forecast report. So as we had with the audit summary, this is a simple markdown file format, but really helpful data to help you plan and inform you what you should configure, what runners you should configure in GitHub Actions. So here we can see there were 81 jobs run across 16 unique pipelines. We have metrics that show the total execution time and the average min-max numbers for each job's execution time. There are metrics for the queue time, so when a job was requested to when an agent was available to execute it, and some metrics around job concurrency. These metrics are also calculated for each queue of runners that you have defined in Azure DevOps, so you are able to know exactly where you're spending the most time running your builds and can set up your runner strategy in GitHub Actions accordingly. The next CLI command that we will look at is the dry run command. Now what a dry run command will do is fetch an individual pipeline, convert it to its equivalent in GitHub Actions, and then write that workflow to your local file system. So let's go ahead and execute this command. So here we can see there are a few files written to disk. Before we look at those files, let's take a look at the Azure DevOps pipeline that we are converting. In this pipeline, we are defining two jobs, one job using the build template with a set of parameters, and then one job with the deploy template with another set of parameters. In the build template, this is an Azure DevOps template, we are running a handful of .NET commands to build, test, and publish a pipeline artifact. And then the deploy template is defining a job that runs after that build template only if we are on the main branch of a repository. Then this is downloading a build artifact and publishing to an Azure function instance. Now the converted workflow is similar here, where the main entry point here is a GitHub Actions workflow with two jobs. One job is using a reusable workflow that contains the build logic. That build logic, again similar, where we are running checking out source code, running .NET commands to build, test, and publish a pipeline artifact. You will notice that the ways that we reference inputs and parameters and predefined build variables are automatically updated for you to make this workflow as functional as possible right out of the gate. Similarly, this deploy reusable workflow is running if we are only on the main branch of the repository. So again, GitHub Actions Importer will convert this condition syntax to make this workflow run as close to as possible as it was running in Azure DevOps. And then here we're downloading the build artifact that was published in the build job and publishing to our Azure Functions instance. The last command that we are going to look at is the migrate command. Now, as you might suspect, the migrate command will again fetch an individual pipeline, convert it to its equivalent GitHub Actions workflow, but then instead of writing that converted workflow to your local file system, Actions Importer will open up a pull request directly on your behalf. So let's take a look at that pull request. Here we can see that there is a pull request description that is constructed on our behalf. As we saw in the audit summary, a manual step is something that must be completed by you, the person performing the migration, for this workflow to be valid. In this example, we are referencing a secret containing our credentials to authenticate with our Azure subscription that are not migrated automatically. But let's assume that we populated those values ourselves. The files that are included in this pull request are the exact same files that were included during the dry run command. Now, this pull request is the most natural place to have any code review or any final polish that needs to be added to this workflow prior to merging this pull request and completing the migration of this pipeline. So that's end-to-end how you can use GitHub Actions Importer to plan, forecast, and automate your pipeline migration to GitHub Actions.